With a better understanding of the data types in Python, let's now have a look at data structures, which are like organizational systems designed to help manage and store these containers or objects. Data structures are therefore slightly more complex than data types, although are easy enough to understand. Here are the four main data structures in Python: lists, tuples, sets, and dictionaries. Let's take a look at each of these in more detail in order to better understand the differences, as each data structure is also designed to handle a specific kind of data. A list in Python is like a shopping list you would use when going to a grocery store. It's an ordered collection of items that you can add to, remove from, or change as needed. For example, a list might be used to keep track of different varieties of apples you want to buy. A tuple is like a recipe. It's an ordered collection of items that can't be changed once it's created. This is known as being immutable, which simply means it cannot be mutated or changed. Therefore, you might use a tuple for a recipe of apple pie ingredients, where the ingredients as well as the order in which they are used should not be changed. A set in Python is like a basket of unique apples, where we can only have one apple of each kind. Sets are an unordered collection of unique items that are mutable, meaning that we can change the elements within a set by adding or removing them. Therefore, we can take a Granny Smith apple out of the basket and replace it with a pink lady. However, sets don't allow for duplicate elements, so if you try to add an apple variety that's already in the basket, such as another pink lady, it won't be added again. A dictionary, or dict, in Python is like a catalog of apple varieties, where each apple variety, referred to as the key in a dictionary, has a description, referred to as the value. This key and value pair system is unique to dictionaries and makes them easy to identify. The dictionary is therefore an unordered collection of key-value pairs. For instance, you might use a dictionary to store descriptions of various apple varieties. Just like with data types, it's important to use the right data structure for the kind of data you're working with and the operations you need to perform. Understanding these different data structures will help you write more efficient and effective Python code. Let's now take a more detailed look at each of these data structures. A list in Python is like a shopping list you use when going to the grocery store. It's an ordered collection of items that can be changed, added to, or removed as needed. For example, you might use a list to keep track of different apple varieties you want to buy. Here is how the code for a list of 3 apple varieties would look. Apple underscore varieties equals opening square bracket Granny Smith, comma, Golden Delicious, comma, Pink Lady, closing square bracket. In this code, apple underscore varieties is a variable that stores a list of apple varieties. Lists are easily identified by the square brackets they use to hold the values within them. We can confirm this by again printing the variable apple underscore varieties within a type function. When run, this outputs class list, indicating that the variable is in fact a list. Let's now take a look at lists in more detail. The order in which you add apples to the shopping list matters. If you add a Granny Smith apple first, then a Golden Delicious apple second, the Granny Smith will always come before the Golden Delicious, as long as they're in the list. When we print the list, the output will be Granny Smith, Golden Delicious, Pink Lady. This output shows that the items in the list are displayed in the order they were added. This is what we mean when we say lists in Python are ordered. Python lists allow for duplicates. Therefore, you can have more than one of the same apple variety in a list. To add a new apple, we use the append method. For example, let's say we want to add another pink lady to the list. In our code, we would type apple underscore varieties and append, opening parenthesis, double quotation mark, pink lady, double quotation, closing parenthesis. When we now print the list, the output will show 2 pink lady entries at the end of the list. This shows that a list does allow duplicate items, but it is still ordered, which is proven by the fact that the new pink lady apple is added at the end of the list. Python lists are mutable, meaning that we can change the variety of apples in the list from one apple variety to another. To do this, we will again make use of indexing. Let's add a Fuji apple to the beginning of the list by using the index 0. Apple underscore varieties, opening square bracket, 0, closing square bracket, equals, double quotation mark, Fuji, double quotation mark. As you can see, we were able to change the first apple variety in the list from Granny Smith to Fuji. This shows that lists are mutable, meaning we can change an item in the list. At the same time, we can also remove items from a list by using the remove method. We can do this by typing apple underscore varieties dot remove, opening parenthesis, double quotation mark, Golden Delicious, double quotation, closing parenthesis. When printing this, we can see that we were easily able to remove golden delicious from the list. This further illustrates the mutable nature of lists. A tuple in Python is like a recipe. It's an ordered collection of items that can't be changed once it's created. This is known as being immutable, which simply means it cannot be mutated or changed. Therefore, you might use a tuple for a recipe of apple pie ingredients, where the ingredients as well as the order in which they are used should not be changed. Here's how the code for a tuple containing 3 ingredients for an apple pie recipe will look. Apple_pie_recipe equals opening parenthesis, double quotation marks, flour, double quotation, comma, space, double quotation, sugar, double quotation, comma, space, double quotation, apples, double quotation, closing parenthesis. As you can see, tuples are similar to lists but use parentheses instead of square brackets. In this code, apple_pie_recipe is a tuple that represents the ingredients for an apple pie recipe in the order they should be used. When you print its type, it outputs class tuple, indicating that a tuple is assigned to the apple_pie_recipe variable. Now let's take a look at the properties of a Python tuple. As with a list, the order in which you add ingredients or values matters. If you've added flour first, then sugar, and then apples, the tuple will preserve this order. When we print the tuple, the output shows that the items in the tuple are displayed in the order they were added: flour first, then sugar, and finally apples. This is what we mean when we say tuples in Python are ordered. Python tuples also allow for duplicates. Therefore, you can have the same ingredient multiple times in your recipe. In other words, we can add a bit more sugar to our recipe in case it's not already sweet enough. When we print the tuple, the output will show that sugar appears twice in the recipe. This shows that a tuple allows duplicate items. The difference between a tuple and a list is that tuples are immutable, meaning that we can't change the ingredients of a recipe once it's been created. If we try to add another value to it, such as whole wheat flour, again using indexing like we did with lists, Python will instead give us a type error saying, tuple object does not support item assignment. This error message is telling you that you tried to do something that's not allowed. In this case, changing an item in a tuple. This is what we mean when we say tuples in Python are immutable. A set in Python is like a basket of unique apples. In this basket, you can only have one apple at each kind. Sets are therefore an unordered collection of unique items that are mutable, meaning that you can add or remove apples from the basket, but we cannot have any duplicate items. The easiest way to recognize a Python set is by its usage of braces or curly brackets. For instance, you might have a set like this. In this code, apple_varieties is a variable that stores a set of apple varieties. When you print the type of apple_varieties, it outputs class set, indicating that the variable is a Python set. Now let's take a look at the properties of a Python set. The order in which you add apples to the basket does not matter. If you add a Granny Smith apple first, then a Golden Delicious apple second, the Granny Smith may not necessarily come before the Golden Delicious. Let's take a look at our code and see what happens when we print our set. When we print the set, the output shows that the items in the set are not necessarily displayed in the order they were added. This is what we mean when we say sets in Python are unordered. Here, Pink Lady was ordered first in the output, followed by Granny Smith, followed by Golden Delicious. This shows that sets are unordered as they randomize the output of the assigned values, which compared to lists which are ordered, retain the values in the output in order of how they were assigned. Let's run the code again and see what happens then. At this point, I unfortunately ran into a bug in Google Colab, which was surprising. As sets are unordered, the values should randomize differently when you print them out each time. However, Colab seems to store the initial output in its memory, refusing to replace it when we run the print statement again. In order to get around this issue and illustrate how it should be working, I had to restart the Colab runtime before running the print statement each time. When doing so, you can see that the set randomizes the order every time we run the code, which is the way it should be working, illustrating that sets are unordered. The manner in which Google Colab handles is thus incorrect. I have reported the issue to the developers, so depending on when you watch this, the issue might or might not have been resolved. I just wanted to make you aware of it in case you didn't see the intended results. Great, let's move on. Python sets do not allow for duplicates. Therefore, each apple variety in the set is unique. For example, let's try to add another Pink Lady to the set by using the add method. Apple_varieties.add opening parenthesis, double quotation mark, Pink Lady, double quotation, closing parenthesis. When we print the set, the output will still only show one pink lady. This shows that a set does not allow duplicate items. Python sets are mutable, meaning that we can change the varieties of apples in the basket at any time. To do this, we will again make use of the add method. This time, however, we won't be adding a duplicate value such as pink lady, but instead a new unique value. For example, let's add a Fuji apple to the set by typing apple_varieties dot add opening parenthesis, quotation marks, Fuji, quotation marks, closing parenthesis. Now let's run the print statement again. As you can see, we were able to add Fuji to the set. You will again notice that the order of a set is randomized with each print due to it being unordered. Therefore, the new Fuji apple can be placed in any location of the order, unlike a list where it was only added to the end. This shows that sets are mutable, meaning we can add new items to a set. We can also remove items from a set using the remove method as follows. Apple_varieties dot remove opening parenthesis double quotation mark Granny Smith double quotation closing parenthesis. When printing this out, we can see we were able to remove Granny Smith from the set. This further shows that sets are mutable, meaning we can add or remove items from a set. A dictionary in Python is like a catalog of apple varieties that operates on a key value structure, similar to a list of different apple types, each with its own distinct label. Each apple type or key in the dictionary, such as Granny Smith, Golden Delicious, and Pink Lady, is unique and cannot be duplicated. These keys correspond to their respective descriptions or values, which could be any form of information, such as green and tart, crisp and sweet and juicy. Thus, we can think of this dictionary as a collection of apple types where each type is paired with a label that describes it. This allows us to have multiple apples but ensures that each unique apple type is identified by its label. Like a set, a dictionary is also enclosed by curly braces. However, inside these braces, the keys and values are specified as pairs. Each key-value pair in the dictionary is separated by a comma, and within each pair, the key and value are separated by a colon. For instance, you might have a dictionary like this. Apple_varieties equals opening braces, Granny Smith, colon green and tart, comma, golden delicious, colon crisp and sweet, comma, Pink Lady, colon sweet and juicy, closing braces. In this code, apple_varieties is a variable that stores a dictionary of apple varieties along with their label descriptions. When we print the type of apple_varieties, it outputs class dict, indicating that the variable is a dictionary. Now let's take a look at the properties of Python dictionary. The order in which you add apples to the basket matters. If you've added Granny Smith apple first, then a Golden Delicious apple second, the Granny Smith will always come before the Golden Delicious, as long as they're in the basket. Let's take a look at this in our code. When we print this variable, we see that it outputs the dictionary. This output shows that the items in the dictionary are displayed in the order they were added, with Granny Smith being first, Golden Delicious being second, and finally Pink Lady third. This is what we mean when we say dictionaries in Python are ordered. Python dictionary keys do not allow for duplicates. Therefore, each apple or key must be unique. For example, you can't have two apples with the same key in the basket. If we try to add a second Pink Lady apple to the basket, it won't work. Let's see how we would go about trying to do this. Adding elements to a Python dictionary is slightly different to the other three data structures that use methods, such as the add or append methods, as we have seen. This is because when adding to a dictionary, there are both the key and values to consider, and not only a value. So to add a key and value pair to a dictionary, we need to use code that resembles indexing, whereby instead of an integer between the square brackets, we are placing the key. In this case, that is Pink Lady, which is a string. Therefore, we need to include its quotation marks. We then assign its value using the equal sign. As this is also a string, we need to again include its quotation marks. Let's use crisp and sweet, but change it to crisp and yummy. When we print the dictionary, we can see that even though we tried to add another Pink Lady key and value, the dictionary instead only updated the description or value of the current Pink Lady from sweet and juicy to crisp and yummy. It didn't add a new Pink Lady key to the dictionary. This shows that a dictionary does not allow for duplicate keys. Take note that in a Python dictionary, only the keys must be unique. If you try to add an item with a key that is already in the dictionary, the old value will be replaced with the new one. That's why keys are often called identifiers. They must uniquely identify an item in the dictionary. The values in a dictionary, on the other hand, do not need to be unique. Therefore, multiple keys can have the same value. Here's an example. Let's change the value or label of the pink lady from sweet and juicy to the same green and tart label that Granny Smith has. Now our code will look like this. Apple underscore varieties equals opening braces, Granny Smith, colon, green and tart, comma, golden delicious, colon, crisp and sweet, comma, pink lady, colon, green and tart, closing braces. When you print this dictionary, you'll see that the descriptions or values for Granny Smith and pink lady are now the same, green and tart. This proves that Python doesn't have a problem with this. Remember, only the keys, Granny Smith, golden delicious, and pink lady, are all different, which is what matters. So in summary, keys in a Python dictionary must be unique, but the values do not need to be. With that said, it shows that Python dictionaries are mutable, meaning that we can change the description of an apple at any time. Let's change the description of the Granny Smith apple. When we print the dictionary, the output will be Granny Smith, extremely green and tart, golden delicious, crisp and sweet, pink lady, sweet and juicy. As you can see, we were able to change the description of Granny Smith from green and tart to extremely green and tart. This shows that dictionaries are mutable, meaning we can change the value associated with a specific key. As mentioned before, only the values or a dictionary are mutable, not the keys. For example, if we try to change Granny Smith to Fuji, it will not change. When you run this code, it will not change the key Granny Smith to Fuji. Instead, it changes the value associated with the Granny Smith key to Fuji. Now the printed output reads, Granny Smith, Fuji, golden delicious, crisp and sweet, pink lady, sweet and juicy. This demonstrates that dictionary keys are not mutable and therefore you cannot change them directly once they have been assigned. And that brings us to the end of this video. If you've made it this far, I sincerely hope that you enjoyed the content and have learned something new. If so, please leave a like and subscribe if you have, as well as to get notified of any future videos. Oh, and make sure to check out this video as well. You can also subscribe over here. And this one is pretty cool too.